Okay, so I'm going to make a few videos going over some of the questions on the most recent quiz that'll hopefully answer some questions that you have. If you have more questions, or if you want to if you want me to go into more depth on any of these problems, just leave a comment or send me an email, and I'll try to do something to address that. So let's take a look at the first problem, which was this word problem. So you have a square or a rectangular sheet of metal that's 2 by 6 inches, and then you cut little squares out of the corners and fold it up and make an open-topped box. And we want to know how much we want to cut into that rectangle of metal in order to maximize the size or the volume of our open-top box. So I'll copy the diagram down here. So we have this rectangular sheet, okay, and on this side it's 2 inches, and on this side here it's 6 inches. And what we're doing basically is cutting away these little corners, and they each have a length of x. Okay, we don't know. Okay, so what happens is after these corners are cut out, we fold up this edge, this edge, this edge, this edge, and we have an open-topped box. So the first thing to really think about is what values can x be? So x obviously can't be a negative value. You can't cut a negative amount of space or length away from this rectangular sheet. But x also has like an absolute maximum value where if you go beyond it doesn't really make any sense. So if we think about it this way, this is a 2-inch side, so this is the shortest side. If we cut an inch in here and an inch in here, we'd really be cutting away all of this side. Okay, so we'd have basically a box with 0 volume. It would just be, you'd fold it up and there would be sort of nothing. So x can't be greater than 1. Okay, so it's sometimes good before you even start trying to come up with an equation to set those parameters. So x is between 0 and 1. Okay, so now that we've settled that, let's start trying to come up with an equation. So we want the volume, okay, in terms of x. Okay, now remember the volume of any box, okay, any sort of three-dimensional rectangular solid is going to be just the length or the base times the width times the height. So we can see pretty clearly the height is going to be x, okay. The length is going to be 6, okay, but we cut x in over here and we cut x in over here, so it's going to be 6 minus 2x. And then the same idea with the width, it's going to be 2 minus 2x, okay? So the volume is going to be the height, which is just x, times the length, which is going to be 6 minus 2x, times the width, which is going to be 2 minus 2x. Okay, so that's the volume. We don't necessarily need to simplify it any more than that. We could, and we could get it as a cubic in descending order, but we don't really need to do that. What we need to do now is go to our graphing calculator. Okay, and if we click on the calculator button, okay, then we hit y equals, and we input that equation. So we do x, and then we do 6 minus 2x, and then we do 2 minus 2x, close our parentheses, and hit graph, okay? And that shows us our graph. So we can see if we go all the way to the left, okay, we're going to be getting smaller and smaller numbers. But that doesn't really make sense because, as we discussed before, you can't cut a negative amount into this metal sheet. Same idea if you go beyond 1, goes down to some minimum value here, and then it just keeps growing and growing. So we're really only interested in this little narrow window here, okay? And we can see pretty clearly there's some value in between 0 and 1, that maximizes the volume of our box in that little window, okay? So to figure out what that value is, we hit this Extrema button, okay? And we want to slide these little arrows here. They're a little finicky. We want to slide one of those arrows there to be just a little bit to the left of that peak. And we want to slide the other arrow to be just a little bit to the right of that peak, okay? And then we hit find, okay? And you see it makes a little point right there, and it tells us our x value is 0.45 and our y value is 2.52, okay? So the x value is going to be our value of x that maximizes the volume, okay? And they ask us to round it to 2 decimal places, so we'd put in for our answer 0.45, okay? And the maximum value, same thing. It's 2.524, so we're going to just round that to 2.52, and that's going to be our maximum volume. And there we go.